Hi, in this video tutorial, we are going to perform supervised classification using the random forest model. So first, I'm going to locate my study area, which is Bulawayo, second biggest city in Zimbabwe. Okay, so I'm going to add a marker, the study area center, and then I'm going to import the boundary of the study area. Okay, and then now I'm going to rename table to boundary. Next, I'm going to import the training areas which I've already created. So the training areas is TA 2020. Okay, and then I'm going to rename table to training areas. But the script for this tutorial is quite long, so I'm simply going to copy the script that I've already prepared and just paste it. Right, so here we go. So this is our script that we are going to use. All right, so we are going to perform a pixel-based classification. So we are going to use rain season Sentinel 2 imagery data. Right, so the first step, we've already done it. We have imported the boundary and the training areas. So the next step is to load in the Sentinel 2 surface reflectance data. So we are going to use the image collection function, and also we create a function to mask out the clouds. And then we are going to clip the imagery to our boundary, and then we can display it. Right, so after that, we are going to load other predictor variables. So here we are going to use elevation, which is derived from SRTM digital elevation model. And we are also going to extract slope from the SRTM elevation model. Okay, then next we want to combine all the raster variables. Okay, so we are going to create an object called input features, which is going to contain the Sentinel-2 data collected during the rain season. So I've called it here rain composite, and then we have elevation and our slope. Right, next we're going to load the training data, and then we will rasterize the training data. Okay, so we are going to focus on the column called class ID, which contains the lane cover classes. Then we are going to simply to rename the classes to 0, 1, 2, 3, 4, 5. So this means the 0 is bay areas, 1 built up areas, 2 cropland, 3 grass open areas, 4 water, and 5 woodlands. Right, then we are going to import, we are going to combine the input features, which are the predictor variables, and the rasterized training areas. Okay, and then I'm going to rename the column class ID to class. So class contains the lane cover classes. Okay, next we are going to extract values from the input features using a stratified random sampling approach. So here we are going to have 10,000 points. Okay, so these 10,000 points, they represent the values or training data for all the lane cover classes. Right, next we are going to partition the training dataset into training and validation data. Okay, so first we are simply going to add a column to the training dataset, which we call random. Okay, so we are going to define a seed value. So here we have defined a seed value of 50, so that we can so that it can be repeated. If we run the code again, we can get the same result. Right, so we are going to split the training dataset into 70% for training and 30% for validation. Right after that, we are going to specify the bands that we are going to use as predictor variables. So we have here the bands from Sentinel 2 plus the elevation and slope. Okay, so next we are going to define the random forest model parameters. So here we are going to specify the number of trees is 100. So we are simply going to keep it small and simple. Okay. Next, we are going to create an explanation for the random forest model. So we are simply going to check the random forest model performance. So we are interested in the out of the bag error rate. Okay. And then we also want to compute the variable importance so that we see the predictor variables that are important in the random forest model. So the predictor variables that is more influence in the model. Right, then we are going to print the chart so that we can visualize the importance of these predictor variables. Right, next we are going to create a confusion matrix so that we check the training model accuracy. After that, we can print the statistics to show the training model accuracy. After that, we are also going to use the test data so that we check the accuracy of the model. So in other words, here we are performing validation using unseen test data. So this is the data that the model has not seen. So after that, we also create an error matrix, and then we print the statistics. Next, we are going to use a filter. Sorry, I said we're going to apply a filter. I'm saying model median, but it's not. So we are going to apply a mode filter in order to remove small pixels that cause salt and pepper effects on the lens cover. So we are simply going to use the focal mode, and then we are going to display the this lens cover map which has been filtered by the mode. We are also going to display the original training areas. Next, we want to calculate the area for each lens cover class. So remember, this the area, the lens cover classes are now in pixel values, so we need to convert them to square kilometers. So we are simply going to divide by 1,000,000 so that we convert them to square kilometers. And then after that, we are going to create a chart so that we can visualize the land cover classes. We can visualize the land cover classes and their corresponding quantities. Then finally, we are going to export the final land cover map. Right, so this is all. So let's run the code and see what happens. Okay, it seems everything's fine. We have our random forest variable importance here. And the out of the bag error rate is quite low, which is 0.09. Okay, we can see that elevation is the most important predictor variable, followed by band 11. Okay, we can also see that we have a very high training overall accuracy, and the validation overall accuracy is quite good also, 0.9. And here we have our land cover classes. Okay, we are showing the built-up area, the bay areas, cropland, grass open areas, and woodlands. And this is our final land cover map. We can quickly see some errors here. A lot of these spots which are misclassified, built up areas. Okay. Right. Thank you very much for watching this video. Please subscribe to my channel if you have not done so. This is important so that you get alerts when I have a new video.